right, and I'm here again with DevOps Talk Conference, and I'm here with one of our speakers today, Chris Harwood. Chris, tell me a little bit about why you're here at the DevOps Talks Conference.
Yeah, look, Nathan, it's a fantastic opportunity for us to actually come and meet the rest of the community here in Sydney that we work with, that we interact with every day, and to showcase some of the interesting things that we've done that might be different or, frankly, might represent learnings that others can resist the same temptation to make the same mistakes.
Right, so tell me about, where do you work?
Work for a company called Health Direct Australia, and we're here providing consumers and other people across the country terrible examples. That will cut that one and do another one.
All right.
All right, cool. All right, we're going to go there. I can do that, sure.
Yeah.
No worries.
All right, so tell me about Health Direct Australia.
Thanks, Nathan. We're here to provide services to consumers across the country. So we help them get advice after hours to make sure they can find the nearest service near them. And it's a great way of resisting the temptation to go to emergency when that's probably not the best place for you to be all the time.
Okay, everything's working. You can all hear me at the back. Excellent. Well, it is very hard to go next after John. My God, I feel like I need, I don't know, half an hour just to think about everything he said, to reflect. There was a lot. But we don't have half an hour to think about John's talk just now. I want to talk to you about serverless architectures. So I think that serverless, and it's been a bit of a buzz lately. It's been a bit of a hot topic. But I do think that serverless, in a way, is a future of software architecture. And I think it will affect all of us going forward in different ways, perhaps. So the way it may affect you will be different to the way it affects the person sitting next to you. But there is something there. And so I just want to talk to you about it. Just a quick hands up. Has anybody used AWS Lambda? Wow, quite a lot of people in the room. What about Azure Functions? OK, a few. Google Cloud Functions? A few as well. IBM Functions. Wow, we have one person. This is more than I usually get, so that's quite interesting. Is this being recorded? Oh, God. Please cut this when the video goes. OK, Igor? Thanks. Yeah, he's saying yes, it'll be cut. So I just came back from Serverless Conf, which is actually our conference, a conference that we organize that's focused on serverless architectures and technologies. And this was an interesting tweet from Barry O'Reilly, the co-author of Lean Enterprise, who said, well, after 3 days at Serverless Conf, I can see that the new world is not only possible, it's on its way. The biggest takeaway, early adopting teams of cloud and now serverless are iterating and adapting exponentially faster than the industry. We know how this story ends and who wins. And there's another tweet from Simon Wardley, who some would say is the prophet of our times. Simon is a famous analyst. He created Wardley Maps, which is a way to kind of think and strategize. I know Amazon uses Wardley Maps a lot to kind of plan out and create a strategy for what they do. And he wrote, the proverbial SHIT will hit the fan when a two-person company produces a function that gets acquired for $1 billion. So that's kind of interesting. So this is me. I am an author of a book on serverless architectures. It's been translated to Japanese recently. I got a copy. I opened it. I couldn't read Japanese. It looks good, I guess. If anybody reads Japanese, please read it and tell me if it makes sense. I'm sure it does, I hope. I started off as VP of Engineering at A Cloud Guru, and I'll tell you in a second about what we do and who we are. I'm now responsible for the education for kind of the product that we produce at the A Cloud Guru. So I'm now VP of Content as well. I organize Serverless Conf, so that's that conference on serverless architectures and technologies. And I'm also an AWS community hero, or they designate me now as a serverless hero, which basically means that I speak probably too much at events about serverless. That's all it is. So this is our company, A Cloud Guru, and we started about 3 years ago with a mission to kind of change the way that people learn cloud computing, right? We decided to become the place to learn cloud. It's a massive online community now for IT professionals as they kind of journey into the cloud. And we've been very busy over the past 3 years. We have trained now over 650,000 engineers all over the world, 170 countries. We've opened offices in Melbourne. We have an office in the US and in London as well. And we've been on this serverless journey from the very, very start. It's interesting. So we didn't kind of set out with serverless because we thought it would be the next revolution. We kind of had a need, and we thought that serverless could kind of fill that need. We built our platform on AWS Lambda pretty much from the very start, and we've been growing ever since. We don't run a single server anywhere in our system. We fell in love with serverless. We saw how quickly it scales, how easy it is to use, to build. Now, there are problems, and I'll talk about them in a minute. But we kind of thought, hey, there is something there. There's something interesting here. So we started this series of conferences, and we ran that conference, Serverless Conf, in New York, in Austin, in London. We just ran it in San Francisco, in Tokyo. We wrote a whole bunch of courses, kind of introducing people to this whole notion of serverless technologies. And by the way, quick plug, if you are interested in kind of creating content or courses covering cloud computing, please talk to me after. We're looking for SMEs or just people passionate in cloud computing to help us create more content. And not just serverless, it could be anything related to cloud, including DevOps, security, very, very, very important. So I guess why serverless? This is just a little table if you're not super familiar with what it is. We basically use a function as a service product called AWS Lambda that allows us to run code on demand when we need it. And you can see that you can run a function. You can see the responsibility there if you go serverless versus a PaaS or an infrastructure as a service system. It's all very interesting. But one thing I want to say is that it's not just about running code in a function and then executing it thanks to an event. It's also about using other third-party services and products, right? So we use DynamoDB and Firebase for our data. We use S3 to store files. We use Auth0 for authentication and authorization. So it's that mix, right? It's the mix of using, say, Lambda or Azure Functions or Google Cloud Functions to execute code and a number of third-party services. And there are also a number of interesting patterns and architectures that come into play as well. But this is what serverless is, right? It's that kind of umbrella term for all these things. So here's just a quick little kind of bit of information about our platform, right? It's entirely serverless, as I said. I just had a look at the stats, and we had 107 million invocations of Lambda in July. Not too bad. So 650,000 users, 107 million Lambda invocations. We had 45 million API invocations through our API gateway. Kind of cool. So this is our footprint. So we have 289 Lambda functions. We group them into a number of microservices. We have nearly 3.7 terabytes of data stored in S3. So these are our video courses. And we have 650,000 users. So does anybody want to guess what our monthly bill was for that month of July? Let's say for Lambda or for the API gateway. Any guesses? Less than $1. Sorry? Less than $1. I wish it was. I wish it was. And to be honest, I think for the first 18 months of our business, we didn't pay anything at all for Lambda, right? Because Lambda has such a big free tier that we just didn't need to pay. But for 107 million invocations, we do have to pay some dollars now. I wish it was free. But it's not actually crazy expensive. It's interesting. So this is our bill for July, right? So our entire compute was $706, right? So this is 650,000 users. Our API gateway was 192. I was actually surprised because I thought API gateway would be more expensive than Lambda. I had this perception in my mind, but I don't know, it was different. Interesting, CloudWatch. So if you don't know what CloudWatch is, it's basically a logging service built into AWS. So it allows your services, so let's say Lambda, to write logs. And we write a lot of logs, as you can see. So we pay over $3,000. And then, of course, CloudFront. CloudFront is a CDN service. So it fronts our files, it fronts our S3 buckets, and we basically pay for the bandwidth, right? So that's $5,000. But it's been kind of disruptive and revolutionary in a way for us, because our entire hosting bill, is under $10,000 for our hundreds of thousands of users. And yeah, it really has enabled us to innovate and move much, much quicker than we would have with a traditional approach. So here's a very, very quick kind of overview of our architecture. This is what it looks like. So we have a single-page app implemented with React. It talks to an API fronted by or created by the API gateway. That API gateway talks to a Lambda function, which is our GraphQL endpoint. And if you haven't heard about GraphQL, it's basically, I guess, a library created by Facebook. And what it does, it allows us to kind of aggregate data from various sources. But that GraphQL endpoint speaks to a number of microservices. And those microservices are made up of other Lambda functions. And sometimes they are fronted by another API gateway. So those microservices can get data for us. They can write data. Typically, they write data to a DynamoDB table. And what happens then is kind of interesting. We use DynamoDB streams, which means that whenever we write to a DynamoDB table, that triggers another Lambda function, which then goes and updates Firebase. So Firebase is Google's real-time streaming database. And that database, that real-time streaming database, directly connects to our website, right? And it pushes changes straight to our website using WebSockets. So effectively, what it means for you as a user, as soon as there is a change anywhere in our data, that update is pushed to our website. So that kind of the usage of our website becomes real-time, right? And if a change made by an administrator gets pushed out to all the end users automatically via WebSockets, via Firebase in real time. They don't need to refresh. They don't need to do anything. Again, we use Algolia as well. We use Algolia for searching, so people can search quickly. And data gets pushed into Algolia as well as soon as a change happens with our data. This is our pipeline. So for deployment, this is a little bit of a lie now because we are replacing Travis CI with BuildKite. So we're moving to a new system. Travis CI wasn't exactly matching our needs, although it is still a good system. But there's nothing amazing about this. This is very typical. This is a very standard setup. We have GitHub. We run pull requests. We test them using Cypress and Jester. Once we're happy and we want to go to a test environment or production environment, Travis or BuildKite does the deployment. So Netlify hosts our single-page application. We deploy our Lambda functions to AWS, and then maybe we deploy updates to Firebase and Algolia as we need to. So yeah, pretty standard setup. So I guess at the start of the serverless era, and I think I'd say it was 2016, around May, there came this notion that serverless means no ops. And I know John hated that. I just know, right, John? Yeah. John was like, oh, you guys, what are you talking about? Of course, serverless doesn't mean no ops. So of course, there are still ops, right? It's just that the responsibility now moves to your engineering team. Moreover, you are now using a lot of third-party services. As you saw, we are purely in a cloud environment, right? We use AWS, we use Firebase, Algolia, Auth0. So you now have to consider the ops teams of those other companies to be an extension of your own ops team. You now have a lot of other third-party dependencies. So you need to know how to escalate when things go wrong. So if there is a failure, how do you escalate something to AWS or to Google, for example? So you kind of need to consider not just your own ops team, but the ops teams of all those other companies that you may end up using. And that's kind of important to know. So still ops, but your dev team is now much more responsible. And so are the other teams of the companies that you use. Second thing, automation, not optional. We have hundreds of Lambda functions. We have all those other services. if you don't automate everything, you are going to be in a lot of trouble. You won't be able to go serverless, right? You need to be able to automate all your deployments. You need to have thorough test coverage. You need to be able to deploy, whether you use immutable environments or something else, but you need to have everything automated from start to finish. Another thing is, it's very, very hard to simulate a cloud environment on your computer, right? So testing is hard. So you need to have a battery of unit tests. You need to have everything testable. You need to have everything testable independently. So we have a whole number of unit tests that covers all the functionality of our platform, and we can run a battery of these tests at any time. So you want to be able to isolate each function, have a number of tests surrounding each function. You need to have that confidence in the operation of your system. So yeah, automation not optional, please. And luckily, there are a number of frameworks that allow you to kind of deploy everything and automate things as much as possible. We didn't actually have them when we started, so we wrote a whole bunch of frameworks ourselves and then had to throw them out once the environment matured a little bit. So look, I just want to share some stories with you. These are stories from our experience. I hope they might come in useful. Maybe you'll get different things out of these stories, and I would love to hear what you think at the end. So front-end and API failover, that's kind of a really interesting one. So as I said, we use Netlify to host our static page application. This is our React app, and back in December, Netlify went down. And we were like, uh-oh, our site is down. Nobody can actually access our website. That's not very good. So we had 48 minutes of outage. And of course, we got emails and complaints from people saying, hey, I couldn't go into your platform. I couldn't study for my course. I couldn't study for my exam. What's going on? And we felt really, really bad because we tried to provide a great service. And we couldn't blame somebody else. This is our platform, right? So we own it. It's our responsibility. So I started thinking, is there something we can build to have kind of health check and an automated failover in case one of the services that we use fails? And I thought, okay, maybe something like this could come into play. And just caveat, we haven't implemented this in production. This has been kind of tested. There's a proof of concept that we've written, but we haven't deployed it yet. But we thought, why don't we use Route 53, which is a DNS service provided by AWS, and implement a health check. So we go to Netlify all of the time, so our users hit Netlify. But if there is a problem, we should automatically fall over to another copy of our website, perhaps a copy in an S3 bucket, which is fronted by CloudFront. It should be automated, it should be nearly instant, and we shouldn't have to be involved if it happens. Cool, so we don't want to see this anymore. So how would we do it? All right, so here's Netlify. This is what it looks like. I deployed a basic website to Netlify just for a test. Deployed the same website to an S3 bucket. Again, simple single-page app, Angular, React, whatever you want to use. Great. This is Route 53. This is what it looks like. So I set up my DNS, and I created a health check. There it is. It's called H5 boilerplate. And what's interesting is that I have a request interval of 10 seconds and a failure threshold of 3, which means that I ping every 10 seconds. And if I get 3 failures in a row, if I don't get a 200 response from Netlify from that particular URL endpoint, you can see on the screen designated by URL. If I don't get a good response 3 times in a row, then I can say that the endpoint has failed, and I need to switch over to another copy of my website. Cool, so this is the record set. This is pointing to Netlify. That's kind of the default choice. This is the second record set, and this is the failover one. This is what will kick in case Netlify doesn't respond quickly enough. All good, this is me. I was actually going to use a face of one of our engineers, but then I forgot. So yeah, just imagine it's one of our engineers. They're kind of like round and smiley. So So here it is, right? So I hit the website. As you can see, HTTPS, there's an SSL cert, everything's good. We're getting this website out of Netlify. There's the server, there's the e-tag. Awesome. Then I went into Netlify, and I hit this big, scary button that said, delete this website. I'm like, yeah, what could possibly go wrong now? Cool. So we can see that Route 53 quickly detected that the endpoint is unhealthy, right? So it's been pinging Netlify. Suddenly, Netlify is reporting a 500 or 404 or whatever status it's reporting. It's actually 404 there. And back to our website, you can see that it switched over to an S3 bucket, right? So seamless. I didn't have to be involved. All automated as much as possible. Yeah, so sure, there was a little lag, about, I don't know, 10 seconds, 30 seconds, I guess, between the switchover. But really, it's better than 48 minutes of people being unable to access our website. So that's cool. So then I thought, can we extend this to APIs, right? Can we extend this to our backend? Why don't we have the same system with our backend? And interestingly, we can. And yeah, there are some problems that you do need to solve. There are some interesting issues with data, but we can talk about it separately. But you could actually deploy your API gateway, your Lambdas, to one region. You can have exact same copy deployed to another region, right? So you have US East 1 in Virginia, US West 1 in California. And then you can kind of switch from one region to another region if there's a failure in one of the regions. That's kind of interesting. In terms of kind of data, yeah, you would need to be able to synchronize data and make sure that it's all up to date. So we use DynamoDB global tables, which is a feature of DynamoDB that allows you to synchronize tables between multiple regions, which is a very powerful feature. And again, we can have a very similar approach. We can have two regions, we can have two configurations, and we can have an API which automatically fails over if one of the regions starts giving us a bad result. So this is the default, right? So we're getting our data from US East 1, I believe, yeah, from Virginia. That's perfect. Then let's say in the API gateway, I changed the setting. So now I require authorization. So I'm not getting back a 200 response. I'm getting something else. And quickly enough, Route 53 switches to the other region. So now we can see that it is California. So you can do kind of this interesting kind of automated failover as well. So that's one story. The other thing kind of we learned the hard way was about making things more resilient. So here, kind of when we began, I built this pipeline. So we have video courses, and we serve these video courses to people all around the world. And before we can serve a video, we need to transcode it to a number of different formats, right? So for example, we need to transcode it to 1080p for high-quality viewing, but we also need to transcode it to 480p if you are kind of on a low bandwidth connection. So we transcode to 720p, HLS, WebM, all these kind of different formats. And this is the pipeline that I built, right? So all serverless, not a single server anywhere, but effectively from a browser, our instructors, our authors can upload a file, which go into an S3 bucket. That automatically kicks off a Lambda function, right? It's all event-driven, all push-based. That Lambda function grabs the file, queues an Elastic Transcoder job. So Elastic Transcoder is another service in AWS that allows you to transcode one video file to a number of different formats. So Elastic Transcoder does the job, creates, 8 different versions of the file, different formats, different bit rates, and pops them into a different S3 bucket. That triggers another event, which goes onto an SNS topic. That SNS topic fans out and calls a whole bunch of different Lambda functions. One of those Lambda functions updates our database, which then kind of updates the UI, right? Because it updates our website because it's all real-time and WebSocket based. So cool, but what happens if one of those Lambda functions fails. It's a problem, right? How do you replay? Or what do you do? Do you notify someone? Do you requeue? What happens? And before this feature, before the dead letter queue feature came out, it was kind of hard, right? We had to build our own dead letter queues and kind of try to recover from errors ourselves. Luckily now in AWS, when a Lambda function dies, you can configure that Lambda function to push a message onto a dead letter queue, which could be an SQS or an SNS topic, right? And then you can grab that failed message and you can try to reprocess it, you can try to requeue it, resend it again, you can notify the administrator, you can do whatever you want. So if you are building these kinds of pipelines, and I suggest that you do, because they're super powerful, just make sure you use dead letter queues and have an ability to recover from an error if your function fails. You could also use step functions, which is a great product that is built into AWS, and it allows you to kind of orchestrate flows as well. But it's a little bit different. It could be a little bit more challenging to configure. Now, this is an interesting one. If you use Lambda, right, and you use a SQL database, you can destroy your SQL database like that, right? You can just kill it, because what will happen? Your Lambda function will open a connection to your SQL database, right? And then another Lambda function will open another connection. And because Lambda can scale like crazy, suddenly you've saturated your connection pool. And you can no longer open any more connections to your database, and everybody's crying, and your users can't use your website. So if you use a NoSQL database like Dynamo, that's not a problem. But if you do use a SQL database, you can quickly destroy it. So you need to watch out for Lambda, right? Actually, its scaling ability is a problem here because it can destroy the database. So you can actually set a concurrency limit on functions. You can say that this function will have a maximum of 200 simultaneous invocations and no more, right? You're not going to go crazy. And by the way, so I think the limit with AWS now is 1,000 simultaneous invocations of Lambda, but you can always pick up a phone and they'll raise your limit to 3,000, 5,000, 10,000, whatever you need. But just make sure that you set the concurrency to something acceptable so you don't destroy your relational database. There are more complex techniques. Here is one. This is kind of where you monitor how many open connections you have to a database, and then your function decides whether you should open another one or maybe not, or maybe try to do something else, or cache a connection. But it's trickier. And I just want to say that, as much as I love serverless and think it is interesting and very powerful, there are some unresolved issues, and there are some gotchas you have to look out for. And this is one. It's hard. A bunch of other tips that I have. One function, one task. Don't create fat monoliths. Don't create functions that do a lot of different things. Have maybe one data transformation at most. In fact, stick with 0 or 1 data transformations. That was kind of a rule invented by Paul Johnston. No state. Not having a state is the secret sauce that allows Lambda and other similar technologies to scale like crazy. Design for failure. Your functions will fail. So make sure you know what happens if they do fail. If you allocate more memory to a function, you will also allocate more CPU and I/O as well at the same time. It's all automatic. If your function is going crazy, set concurrency to 0. It'll be a kill switch, right? You'll stop that function immediately, and it will not scale anymore. Keep permissions and roles very tight. So you want to have just the minimum amount of permissions allocated to a function. Don't grant it all. Serverless cancer. This was coined by Rob Gruhl from Nordstrom. So I had this happen to me a few times. So serverless cancer occurs if your functions kind of run in this exponential manner. So this is what happened to me. I had a file in an S3 bucket, which invoked a Lambda function. But then that Lambda function, unfortunately, created 2 new files and placed them into that same S3 bucket. So now you can imagine what happened to me then, right? So 2 new files in an S3 bucket, which called 2 more Lambda functions, which created more files. Now there are 4 files. and it just went in a loop. And suddenly I had like 1 million files in my S3 bucket, and Lambda was going like crazy. So that's serverless cancer. So try to avoid recursion if possible. Luckily, I stopped it quickly enough and didn't incur a huge bill, which was nice. But just watch out. I would say that serverless monoliths can be okay initially. And what I mean by a serverless monolith is this. When we began, we had a single database, right? And we had a whole bunch of Lambda functions writing and reading from that database, right? So we didn't have a microservices approach. So a microservice to me is basically an isolated unit of capability that has its own data, its own logic, and it's wholly isolated. Instead, we really had a monolith, right? One database, and everything was writing and reading from that database. But it's okay to start like that. You know, if you're just starting out, it's not a problem. With serverless, you can actually refactor and re-implement a lot quicker than you can with kind of the more traditional approaches to software engineering. We went kind of from that serverless monolith to a more or less proper microservices architecture very quickly, because all we had to do was change our serverless YAML file and re-implement some of the logic. We didn't have to re-provision any hardware. We didn't have to set up any servers. We didn't have to worry about containers. We didn't have to worry about Kubernetes. This was much it was actually easy, which is incredible. Incremental architecture is not dirty. That's the same thing. So go with the monolith and start kind of refining and rebuilding as you go along. And check out step functions in AWS or durable functions if you use Azure for kind of durable for workflows, basically. I also want to touch a little bit about patterns and architectures. And I've been working on this book with Tim Wagner, who invented Lambda, and we started looking at kind of what are the most useful architectures and patterns you should know once you go serverless, right? And we started looking, and it was like, oh my God, there's just so much. There's orchestration patterns and API patterns, traditional patterns. There's the compound patterns, which are like combinations, like CQRS, workflows. It's kind of incredible, but they're also not super hard to build, which is interesting. So I'll just touch on a few that I have personally found very useful. So this is the API proxy pattern. And this is where you have a mediator that sits between two systems that cannot communicate with one another, right? This mediator kind of transforms requests and response payloads to facilitate the exchange of information. And of course, you don't need to go serverless in order to do it, right? These patterns have existed, for decades. But we've just found that when you do use functions, they are kind of easier to implement in a lot of use cases. So here's an example, right? So let's say you have a system A that only talks in JSON. Say you have a system B that is an XML system, right? You can't put an API gateway and a function between these two systems and allow them to talk to one another. I know that there is a big government department that did exactly that. It was a federal government department, and they used Lambda and API gateway in order to allow kind of services to talk to one another, because it was very hard to re-implement those legacy services, right? They had SOAP-based services that spoke XML, and it was difficult. And so that's what they built, right? They had this awesome layer around these legacy services, which they found very effective. Fan-out, I'm sure we've all used fan-out. It's basically gives you a way for multiple endpoints to receive a copy of the event, right? So you have an SNS topic. You can push something onto it, and it will fan out automatically to as many different subscribers as you want, right? You just configure the subscribers. They could be Lambda functions, could be something else, and they will all receive a copy of the event. An interesting thought piece, and there is an answer to this, but how would you design a transactional fan-out, right? So you want to have a transaction. You want to be able to roll back a change. How would you do that? There is an answer to it, and if you want to chat about it, we can do it after my presentation. Inline stream transforms, super easy to do. So these facilitate the transmission of data between systems, right? So as it says in the description, you can demultiplex at the source or destination, and you can have a transform function that helps you do this. So if you use Kinesis streams, for example, you can have a transformation function that sits on top, and as you push data into a Kinesis stream, it will take the data, transform the data, and push it further into the stream so that your consumer receives a transformed packet or transformed bit of data. And it's all seamless. So as you can see there, it's actually the same stream. We don't have two streams there. It's just a transformation function that sits on top. And so if you use, again, something like Kinesis streams, you can kind of quite easily implement this kind of functionality. So we can go on and on and on talking about these different patterns, these architectures that become quite powerful and easily implementable when you go serverless. Again, I don't want to say that serverless is a silver bullet to everything. We'll be using containers, we'll be using servers for a long time to come. There are a number of limitations when you go serverless. Just the timeout limitation itself is big. So your Lambda functions will expire after 5 minutes, right? They'll time out after 5 minutes. And if you cannot decompose your task, then maybe using functions isn't right. So let's say if you're trying to download a file from an old FTP server, right, and it takes 20 minutes, you cannot use a function to do it, right? It will just time out as it happens. So it is not the most appropriate technology for all the use cases, but I think it's actually becoming more powerful and more mainstream day by day. And by the way, if you do get into this problem, so let's say you do have to kind of grab a file, and it takes 20 minutes. What we found is that people create hybrid systems. So they actually spin containers if they need to perform a function that takes more than 5 minutes. That container grabs the file or performs that action, and then the container dies. So systems are primarily serverless, and containers are spun up just to perform a function, perform a capability that a function cannot do. So I don't know, it's an interesting hybrid approach that may be worth of consideration for your use case, perhaps. That's about it. I just want to say, look, it's fun, it's exciting. Getting into this is very easy. The barrier to entry is very small, right? You can jump into AWS, you can start writing functions. If you have legacy systems, you can start just gradually tearing away at functionality in your legacy systems and implementing functions, right? You don't need to go all in from the very start. You can implement a couple of functions, see how they work, see if they add value to your system, and then proceed if they do. Check out some of these sources. We will have a whole bunch of videos available from our recent San Francisco Serverless Conf. There are some really interesting talks on security and DevOps as well, which I encourage you to have a look at. This is, again, a plug for my book, but yeah. So thank you so much. I'll be around all day. So yeah, if you want to chat about serverless or how we've built things, I'd be happy to do so. Thank you so much.